Hello, welcome to the second in the series of tutorials on using Structures Office. And what we're using here is the free edition. So everything that we're going to do, you can do in the free download from structuresoffice.com. I'm going to build up a extruded angle, something simple. There are higher level functions for doing that, but I'm just going to build it up with these simple shapes here. So let's go in and get started. Let's call this the lower flange of this angle. And you'll notice on the corners there's these points, 1 through 4, and they correspond to these bowl downs for origin point and direction. Origin point goes with these two coordinates. So whichever point you pick on that section, if I pick 4, that object will be positioned with point 4 at these coordinates. The direction point, the origin point and the direction relate to this section, and it defines the vector from 1 to 2 will be positioned so that it's rotated 22 degrees counterclockwise from the positive x-axis. I'm going to give it a let's say 10 and 1 and 90 and 90 to start, and then I click add. Oops. Okay, so now let's say I don't like that. Okay, angle 1 is this angle here. Let's make that 33 degrees and edit it. So now I've got this shape. Maybe that's too much. Say 20. Oh, 70 I should say. So now I've got something I kind of want to use. And then let's position another trapezoid, and we'll call this the upper flange. And let's say I want to position that off of point 3. That's that point. So if I go and I want to, now look, if I click on a location and I pick on this section, the coordinates are going to be entered in here. If I picked up here, it would be this coordinate, but I picked down here. Oops. Escape to clear the picks and set it back to 0. The rotation, let's say I want it to go from 3 to 4, and I'll set the rotation. I'll click here, and 2 points define a angle. You always want to use, whenever possible, these positioning points to build up a shape because it's more accurate. And let's just add that for now. And let's change this upper angle back, or this one to 90. Let's do 90. And edit. And let's say, now I'm going to show position points. I want the base of this upper flange, I want to be in line with this. So I need to know what that angle is. So if I go and click 3 points, let's turn this back off for now. Let's click these 3 points, 1, 2, 3, and I go over to angle of 3 points. That says that's 70 degrees. So if I make my angle 2, and you notice that 202 is here, it's because the focus was here. I picked this point and this point, and that's that angle. So that's not what we wanted. We wanted a sweep angle. So if I set that to 70 and edit it, now that lines up with this vector. And now let's put a fillet in there. Let's go over to fillet and let's position it. You see our 1, 2, 3 points. I'm going to position point 1 at here. And those are those coordinates. Rotation. Okay, let's go click, click. That's 22. The radius, let's make that say 1. Sweep angle. Anytime you have sweep, it's 3 points. So 1, 2, 3. And let's add it. And let's say now we want to add a rounded corner out here on the end. Let's close that and open up a sector. Let's okay, that's similar to the fillet. There's 3 points. I'm going to position that here. I want my rotation to be, well, let's go 1, 3 just to be different. And I'll go these 2 points. That's that vector. And let's say the radius. 2 points also defines a length. This sweep is 90 degrees. Now I got a little tab on the end. Let's say that this one we want to do slightly differently. So let's go up here and pick a point. No, I don't want to use this. I want to use a fillet. Do what I want to do here. So let's position it up here. Let's give it a rotation of these 2 points. Let's give it a radius of these 2 points. And let's give it a sweep of 90. And let's change the sign to negative. Okay, and now that's going to trim off that corner. And let's say I want to cut a bolt hole. So let's add a rectangle. And I want, so let's say I know it's, let's say I want to position it, say 5 inches from the tip here. So let's go to define, pick these 2 points, and say point at distance. So I'm talking about moving along this vector from the origin point. Let's say 4 is good enough. Okay, that's a point. Now let's change the sign and let's change the rotation to this way. Make that 1, 4, and let's make the length 3 just for, and say 0.85, and then let's add it. Whoops. I want to position it here and change the sign to a negative. Okay, so now you'll see that that's our angle build up. You see we got this big negative area. I just want to do that to illustrate what this union is for. If I turn on the union, it will chop that out, and we've got an accurate section. So now let's go back, undo that union, and let's edit that and make it exactly what we want. And edit it, and let's close it, and let's turn the union on again. Now, the union's kind of a complicated piece of software, and if you have objects that have got slight overlaps or slivers between the sections, it makes it much harder on the software to do it and to do the calculations. So by positioning, using these points on the section, you get good, accurate build-up. So whenever possible, use those points. Now let's go over and do the computations, section properties computations. Okay, so here is your section properties. Let me talk about these for a minute. These bring up a wiki page in case you forgot what some of these things, how they're defined. It's just a little quick and helpful thing. Here's your area. You see U, and these are units. So whatever units you're using, if it's centimeters, it's centimeters squared, where the center of area is, and principal angle. Here's your moments of inertia relative to the centroid. Here's relative to the axis system. Now if you want to see sections in different axis coordinate systems, you're going to have to do a rotate and translate. The radius of gyration, about the centroid, the polar radius of gyration, the centroidal, and principal. Here's your section moduli and the principal moments of inertia. One thing I like to do, to just do it as a sanity check, is grab those. Let's just save that for now. Let's close that. And now let's go back and turn the union off. And then let's do the calculations again. We should get the exact same results because the geometry matches exactly. And let's bring that back and compare them. This is what I do as a quick check, make sure everything matches, walk through each one of those numbers and see that they match, and they do perfectly. Okay, so that gives me a good warm feeling because all of these shapes, the geometry is all defined with rational B-splines. So the way it's computing, it doesn't compute section properties for a rectangle or a fillet, or it computes a closed shape defined with B-splines. So whether it's a rectangle, goes through the same procedures. So this is a good check because it's comparing two totally different geometries and getting the exact same numbers. So that gives me a good feeling that things are working. And I can write those out into an XML file, and then you can go through that, parse that XML file if you want to tie this in with another program. So let me just talk a little bit about some other features. There's multi-documents, so you can have several different sections defined at the same time. And whatever document is active at that time is what your section properties are going to correspond to. So and just keep that in mind, that your active document is where it's happening. So if you do a save, it's saving this section, not this section. It doesn't do both, only does one at a time. So just be aware of that. Whatever is active, whatever is on top is active, that's what these functions apply to. A couple of things about keyboard accelerators. Your arrow keys on your keyboard will do a translation. A shift arrow key zooms in and out, and escape undoes a pick. And I think that's it for now. I hope you enjoy this program, and please contact me if you've got any questions. We'll be happy to help you out, me or someone else. And good luck, and please enjoy using the program. Thanks for listening.